Hey everybody, welcome to our first lecture for M-Engine programming. My name is Jeff Ringenberg. Unfortunately, I'm out of town right now for the next few days and I won't be able to make it into class for the first and second lectures. But I put together a couple of recordings here to help get us started so that when I am back in class, we can move real quick through the material and ultimately get us to the point where we can start working really hard on the projects and the main focus of the summer, which is what's called the team hack. All that stuff, I'll give you more information about that as the semester progresses. I'll talk a little bit more about it today as well. But today's lecture is pretty straightforward. We're just going to go through the fundamentals of what the course is going to look like. I'm going to show you a little bit of the programming environment that we're using and the language, which is MATLAB. And then we'll discuss what the modern programming toolbox looks like for today's engineer, which is highly dependent upon using AI as an assistant. All right, so as you'll see, AI, whether it's in the form of Copilot or ChatGPT or Google's Gemini, AI is going to be a fundamental part of the way that we approach this course. This may not be the case for later classes that you take here at the University of Michigan. Everybody has their own personal views on it, but my personal view of using AI is that it's basically here to stay and that we should be using it as an assistant for all the work that we do moving forward. So anyways, don't want to go into that in too much detail right now, and I'd like to just focus on what we're going to talk about today. All right, so first off, before we even jump into the slides for lecture, I want to go through a few course logistics. All right, so first off, our course is going to be managed for the most part in a learning management system called Canvas. A lot of you are probably already familiar with this. It's an integral part of the way that we run our courses here at the University of Michigan. And I'm not going to go to our Canvas site directly, but I will show you some of the things that are going to be linked to from our Canvas site, right? And so the first one of those things I want to show you is our Google Drive. So here's our Google Drive. Obviously, this is my instructor's view. You can see I'm logged in up here in the upper right corner, but your view of this is going to look roughly the same. You'll be able to get to this Google Drive through a link on our Canvas site. And right now it's pretty sparse. There's a folder here for labs, and there's only a couple of labs there right now. Those will fill in as the summer progresses. Same thing goes for the lectures. There's just today's lecture and then the next lecture, which is coming up in a couple days. And then a products folder, which is currently empty. That will fill in, of course, as we get through the material and give you the tools that you need to start working on those projects. And then finally, we have our schedule and our syllabus. So what I'd like to do next is go to the syllabus to just give you a feel for what our course is going to look like moving forward. So see if I can zoom in on an appropriate level here so that we can read it. All right, so syllabus first starts off with just a little bit of an overview of what the philosophy of our course is. As I said, AI is going to be a really important part of the way that we teach programming and the way that we try to solve problems and things. And so, AI is going to be a very big component. But like pretty much everything that's related to AI these days, sometimes it doesn't get things 100% correct. Okay, it's getting better and better every day. However, our role as a professional engineer is to be the lead in situations where we're using AI. So we need to make sure that we're constantly able to tell the AI what to do, and then verify what it's done, and then if it messes up, figure out what it did wrong. In other words, debug the issues. Okay, and as I said, this is a specific approach to using AI for our course this summer, and this next part of the syllabus here talks about how other courses might not have the same approach. In particular, courses that are foundational in computer science and programming. All right, as you'll see as we move through the semester, we do use AI to do a lot of the things for us, but in order for us to understand sort of what the AI is doing and the code that it generates and how it works and so on, we ourselves have to have a really good understanding of programming itself. And so just asking the AI to do everything for us and then expecting ourselves to understand what it's doing after it's already done it for us is pretty much impossible. Okay, so we're going to sort of take a hybrid approach where we do some work on our own, where we try to solve problems using our own skills in programming, and then we ask the AI to do the same thing, and then we can compare and contrast those things. Sometimes we'll ask the AI to do a little bit of extra work built on top of work that we've done, and so on. But the important thing to note here is as I'm highlighting, the key skill of a successful engineer is adapting to the requirements and goals of the task at hand. And sometimes the task at hand is adhering to the rules and policies of a course that you're taking that may not have an approach to AI that is the same as what we're going to take this summer. Okay, I personally feel and use AI all the time. I personally feel that it's here to stay, and it's going to become even more and more useful and powerful as the models and things are trained and get better and better and have more data to work with and so on. But that still doesn't mean that we can just sit back and just not learn anything anymore. That's just not how it works. We have to sort of walk through the journey hand in hand with these tools and use them in an appropriate way. Okay, so the learning objectives that we have here for the course, as I said, we're going to be using MATLAB as our programming language. And so basically what we're going to do here is we're going to walk through just the basics of MATLAB programming. There are later courses, obviously, that you'll be taking that will go much deeper into MATLAB and talk about a lot more of the intricacies of what it can do and how it can do things, and even tools that are specific to a certain discipline like aerospace engineering or mechanical engineering. MATLAB spans all the different disciplines of engineering with respect to what it can do and the tools that it provides. It's not just a tool for people to write programs. Okay, for the most part, it is a mathematics laboratory. I'm pretty sure that's what MATLAB is short for. All right, and so what we're going to be using it for in particular here is we're going to use it as just one of many different types of tools that are out there for learning how to apply and develop algorithmic thinking. We're going to apply this type of thinking to solving complex problems, trying to break things down into logical steps and so on. And we're going to do this both with manual coding and also AI prompting. Okay, so we're actually going to do some of that in this lecture today. And then, hopefully you'll get a chance to do it in pretty much every lab and every lecture moving forward. All right. As I said, we're gonna also have to have this ability to debug and verify the code that comes out of these LLMs. So we're gonna, in a sense, develop a way of critically thinking about the outputs of these LLMs that will serve as a skill for you moving forward, pretty much in any discipline that you choose. All right. Let's see. Pretty much the rest of this stuff is things I've already said. We may touch on the Arduino platform towards the end of the summer. I'm not entirely sure if we're going to make it that far or not, but my goal is to apply all the tools that we gain in MATLAB, doing more general purpose type problems, and apply those to a quote unquote physical system like the Arduino platform. Some of your other courses this summer might be using an Arduino platform, which you could leverage for this. Some of you might already have used Arduino in the past, in high school or something. You might even have an Arduino of your own. They're really inexpensive. You can get them on Amazon with all sorts of tools and sensors and everything for less than $50. So it's a really useful platform for doing so-called physical computing. So anyways, couple of notes here about the course structure and the logistics moving forward. Obviously, I'm Jeff Ringenberg. I think I said my name, but anyways, that's me. There's my email address. The lecture location, obviously, we're not there, or I'm not there right now, is going to be in 1500 Eeks in the Electrical Engineering Building. The lab location is in Pierpont Commons. That's the plan, at least moving forward for right now. It's possible that there's going to be some construction happening down in Pierpont Commons in the next few weeks here, and we might just end up having to have our class entirely held here in 1500 Eeks, but that we'll just take it how it goes and see where we get with that. We do have a more detailed schedule that has all the various topics and due dates and things that we're going to be working with this summer. This is what the schedule looks like. It's a little bit hard to see. Let's see if I can make it a little bit bigger here. All right, so as you can see here, there's a couple of different colors, I guess, associated with the schedule. We have the light blue part, which is what's considered phase 1, and so this is a bunch of lectures and labs. Basically, we're trying to get all the basics of programming out there for you to see. Today we're talking about just the fundamentals. On Thursday, a couple days from now, we're going to start introducing functions and problem decomposition. And then the following week we'll start talking about visualization, graphing, plotting. We'll talk about how data is represented in MATLAB specifically. Then we'll shift on to logical operators, iteration, selection, all that kind of a thing. And then we'll finish up the lecture portion of the summer talking about a couple of advanced topics, so vectorization, and then potentially, talking about working with Arduinos. So this might seem a little bit compressed, and relative to when I first started teaching in M-Engine, believe it or not, I started teaching in M-Engine like all the way back in like 2008 or 9, like one of the first times that it was offered. And back then, we had more time, and we also had a lot more lecture space, in other words, to sort of fit things in. But as time has moved on, more and more students that have come into M-Engine have already had prior programming experience. And so what I've realized is that, we don't have to devote the entire month or so that y'all are here, 5 weeks that y'all are here, to covering everything that we possibly can about programming. And instead, what I've done here is I've sort of broken up the summer into two phases. The first phase, this is the one we're currently discussing, is filled with lectures where we're introducing sort of the basics of programming, and we have some labs that are associated with each one of those things. And for those of you that have programmed before, some of this stuff might seem like review. I know that there are going to be some of you that haven't programmed before, and really I want to be able to teach this course for those folks, the folks that haven't programmed before, not the folks that have. This course is not intended to be an advanced programming experience. This is supposed to be just like the fundamentals of how to program in MATLAB and so on. And so, I'll do my best, especially when I'm in person and can have the ability to ask if there are any questions, to slow down and answer those questions if they're out there. But I'm also going to do my best to only give you just what you need to know to do the projects and to participate in the second phase of the summer, which is referred to as the Open Project Studio. Okay, so let's talk about that now. So the Open Project Studio is, as you can see here in the spreadsheet, it starts off with a couple of work days for you to get going on the projects. So the projects are they're associated with the material that we've covered in lecture. They're fairly straightforward, especially with the fact that considering the fact that we have these powerful AI assistants to help us. But then the bulk of the Open Studio is devoted to this activity that I briefly mentioned in the beginning called the Team Hack. Okay, and the Team Hack, if any of you have ever heard of it before, is kind of like a hackathon. Okay, except it's spanning not just a weekend or a couple of days. It's spanning a solid, let's see here, 7 days or so. And also any free time that you want to devote to it as well. And so what we're going to do here is, starting on the 14th of July, everybody's going to get together in teams and form groups that are going to essentially make a cool project. Okay, we'll talk more about what the Team Hack looks like later on as we get a little bit closer, but that's basically what it's going to be. It's going to be this sort of open-ended experience where y'all get to work in teams and show off your skills. Okay, some of you that have programmed before will be able to show off a lot more skills than others. Those of you that haven't programmed before, the goal here will be for you to learn from those people that have. Okay, so it's going to be both a teaching and a learning experience at the same time. And so we're essentially going to devote all of our lecture and lab time to this Team Hack development. So during that time frame, assuming that it's open, we'll be hosting everybody in Pierpont Commons exclusively. We won't be doing any lectures anymore. The formal lectures will essentially finish here on the 8th of July. There's also a practical reason why the formal lectures are going to end there, because on July 9th, I have to go in and get some hip surgery. And so I will not actually be able to stand for a few days here in front of lecture. And so my goal here is to, I'll talk more about this again as it gets a bit closer, but, during this open studio time, I'll be available to assist you all, maybe in person, but probably not, because I'll just be recovering and I won't be able to walk around. And if I do walk around, I'll probably have to sit down a lot, and it'll just be logistically obnoxious. And so I'll make myself available via Zoom and things like that. But I'm really hoping by July 24th, so just a few weeks after the surgery that I have, that I will be able to come in and see your final demos. Okay, so on this date, on Thursday, the 24th of July, we're going to have a Team Hack demo day where everybody gets to show off all the cool things that they worked on and developed during the Open Project Studio phase. Okay, I've been doing this in M Engine for several years now, and some of the work that students have been able to put together has just been phenomenal. And in the last couple years, last year specifically, some students were able to do some really amazing things because of the fact that they were able to leverage AI. All right, AI has been a huge boon, success, whatever, for programmers. There's all sorts of subtle nuances to it, and as we get through the material and we have our labs and lectures and things, and we'll hopefully be able to tease out some of the more finer details about where AI is useful and where we really shouldn't rely on it too much and so on. But the general consensus among myself and my colleagues, and just even people that I talk to, randomly, like my wife's colleagues, for examples, is that just AI is doing some phenomenal things, and we need to embrace it, because if we don't, others will, and we'll just be left in the dust, looking around and saying, where'd everybody go? And they're off there with the AI doing some amazing things. So anyways, that's the basics of the schedule. Let's head back to the syllabus here. The next part of the syllabus here, this just describes in a little bit different way what the two phases look like. As far as required tools are concerned for the course, MATLAB, obviously. It's a freely available software package to all U of M students. There'll be more info on this in Lab 1, where you'll actually get to sit down with your computers and download it and play around with it a little bit. You don't have to get anything fancy with MATLAB. The very basic package will do. MATLAB actually comes bundled with an LLM-based coding assistant, Copilot. All right, that one's built into MATLAB, but you can also use other tools like ChatGPT or Gemini. But from what I've seen so far, the Copilot integration into MATLAB is incredible. This, at least to me, is the first time I've ever seen it here in 2025, and the things that it can do are just mind-blowing compared to what was available just like 2 years ago. Okay. All right, so we also have a supplemental textbook, but I don't teach from the book. This is really just if you're interested in digging really deep into MATLAB, or maybe having access to a MATLAB textbook for other courses or things. There's a link to this here in the syllabus. It takes you to an external website where you can log in using your U of M credentials, and then you can get access to that, and so on. All right, so next section of the syllabus here talks about how we're going to do grading and assessment. Given that this is a summer program in M Engine, and the grades are not going to like enter into your transcripts or anything like that, or impact your graduation, the grading here is very I don't want to say easy, but the grading it's not like the focus of the course. Okay. We have the lab assignments that I briefly mentioned, and then participation, obviously, and then we have the 2 projects, and then we have the team hack. But as far as grading these things is concerned, it's probably better for you to just look at the percentages that come after each of these to give you a feel for what level of importance is placed on those deliverables. So, like for example, Project 2, which is the game of life, A third of the course is considered to be associated with that project. It's a fairly significant project. We've been doing it for years. It's a fun project. In the age of AI, though, whether or not that occupies 30% of your actual time, it remains to be seen. Okay, a lot of these labs and projects and assignments, if you just feed them into an LLM, they're just like done instantaneously for you. But that doesn't mean that you actually learned the material. So, I really want you to keep in mind as we move through the summer that if you are sitting back and just letting the AI do all the work for you and you're not actually taking the time to verify it and make sure that it works and so on, you're doing yourself an incredible disservice. And that is going to, carry forward into your career as an engineer, and you're not going to be able to develop the critical thinking skills that are necessary to work with AI and use it as a tool. And instead, you're just going to use it as a crutch, basically. And so that's not what we want you to take away from this course. We want you to take away from this course the ability to work side by side with an AI assistant, with the understanding that you're the one who is in charge, you're the lead engineer, and the AI is just sort of there to get rid of the more mundane tasks, or maybe make some astute or unique observations that you might have missed in the process. Okay, with the ultimate goal that you understand what the AI did. Okay, now it may be the case in the future that AI gets so good at doing things that we don't necessarily understand how they work. And actually some of the big companies like OpenAI have made statements like that, where they say, yeah, our AI works, but we don't really know how. All right. So that's not the intent of how I want to approach AI in our course. Okay. This is too foundational, too introductory of a opportunity for us to just have it do everything for us. We need to be able to build up those core fundamental skills and work in tandem with AI to develop those. Okay. The last little bit here is just a further elaboration of the quote unquote lead engineer policy that talks about, how you can collaborate with humans and how you can collaborate with AI. This short little description here on human collaboration, it talks about, for those assignments that are deemed individual in this class, so essentially the labs and projects, we want you to do those by yourself. Okay, you can talk about them at a really high level or conceptually with your friends or whatever, but we don't want you to just look over your friend's shoulder and copy and paste, because that's even worse than having the AI do it. Because in that situation, you're not even learning how to prompt the AI to do it. You're just copying and pasting somebody else's work. Okay. Directly copying it is technically a violation of the honor code. And this kind of language used here in mEngine, it doesn't have as significant of a meaning as it would in a later course. But I'm putting it here because this is a really important thing to keep in mind moving forward into engineering, that a lot of the courses have very strict honor code policies, and they don't want to see you copying work from other people, because at the end of the day, we are here to teach you and we want you to learn, and in order for you to do that, you have to do the work. Okay, that's like one of the leading lessons about our class. Okay. And then finally, this discussion here on how to collaborate with an AI. Golden rule here, as I've already mentioned several times, is that don't submit code that you can't explain or defend. Okay, if you haven't taken the time to verify and understand and maybe even modify the code that comes out of one of these tools, you're going to be at a loss in the future. Okay, if you haven't taken the time to do that, you're not going to learn much. All right, so make sure that you take the time to do that, and so on. And also attribute the work to the AI. Like if you are using ChatGPT or Gemini or Copilot or whatever, and you're just using the results from those things to complete some of the work for your projects or whatever, make sure that you attribute it to those sources and make it clear that you did this, verification and debugging step. All right, we want to make sure that you're doing this, and And you know, it's kind of hard for us to do that if you don't attribute your sources. Okay, you're not going to get in trouble if you do it. We just want to make sure that you attribute the work that is done by those tools to where it came from. Okay, I think that's pretty much it for the logistics here with the schedule and the syllabus. So now let's just jump into the lecture here. So as I said, you know, today is going to be a pretty light topic. We're just going to go through a couple of examples. I'm going to show you how to use an AI, and then we'll be done and you can go to your first lab. All right, so let's start off with just a basic description of what programming is. My expectation is that the vast majority of you have programmed before, and if you haven't, you have a general sense of, you know, what it is. And programming in and of itself is really just a form of computational problem solving, okay, or algorithmic problem solving, if you're familiar with the word. All right, and an algorithm is very simple. It's just a set of instructions for a computer to solve a problem. It's very straightforward. It's just a set of instructions for a computer to solve a problem. So that problem could be something as simple as calculating the trajectory of a football after you kick it, to as complex as running a large language model for, you know, AI. Right, so programming is involved in all those different things, but at its core, it really is just a set of instructions for a computer to solve a problem. Okay, in this class, as I said before, one of our main philosophies here is doing the work. So I do and I understand, and so that's why the bulk of your time is not set aside for these lectures and labs, and it's actually set aside for you to go out and do the work and explore things with your teams and with your AI assistants and so on. Okay, so let's jump in and start doing some of these things. So next, we're going to start off with a really simple little example here. So this is the quadratic formula. I personally haven't seen this thing for literally decades, since I took a math class, but I do use it as a programming example quite a lot, okay, because of the fact that it's a very familiar formula, and it has just a couple of these little things called variables in it that we use to store data. Okay, so you know, if we look at this quadratic formula, and if we wanted to solve for x, so we start off with the initial equation ax squared plus bx plus c equals 0. We have this equation that we can use to solve for x. All right, and we can typically solve this by hand pretty quickly, as long as we have, you know, a calculator, because no one wants to calculate square roots by hand. It's just beyond awful. I think I did it once in a math class, and I never want to do it again. You know, so as long as we have access to a calculator or some sort of a computing device that works just with basic numbers and the square root function, you know, we can do this by hand quickly. But what is a challenge is if we had to do this many times. Okay, so say for example, you know, we had a whole bunch of quadratic equations that we had to solve, like a whole file full of them. Or we were doing some sort of a simulation, and these types of, you know, series of equations were there, and we had to solve all the equations in order for us to actually do some work with the simulation. Well, we wouldn't want to do it all by hand. It would just take too long. And so an engineer would typically sit down, or a programmer for that matter, and build a tool to do this. Okay, so that's what we're going to do here in the next few slides. Is we're going to build a real simple MATLAB program, sometimes referred to as a script, that is going to take as inputs the values for A, B, and C, and then it's going to use MATLAB as the calculation tool to calculate the value or values for X. Okay, so given that, here's the workflow that we're going to apply to this. So a modern engineer, just like an engineer since the beginning of time, always starts with a problem definition. Okay, so a problem to solve. In our case, it's the quadratic formula. All right. In the past, they would sit down with that problem definition. They would go through the problem. They'd try to understand it. They'd apply the knowledge that they had learned in the past, and then they would try to arrive at a solution. Well, that is changing a little bit. Okay, with the advent of AI. So the modern engineer's workflow looks like this. You start with a problem, then you get some assistance from an AI to essentially do like a first draft or a first stab at the problem. And then once that's done, humans get involved. You, okay, you, the lead engineer, you get involved to verify and refine the solution that the AI generated for you. Okay. Now, this isn't always going to be the workflow. I mean, sometimes you don't want to get the AI involved. There are some problems that, at least right now, AI isn't very good at. Okay. You know, people like to say that AI is really good at being like a companion or a therapist or whatever, but a lot of studies have been coming out. In fact, just a couple days ago, I saw one out of Stanford that has said that it might sound like it's a good therapist, but it's actually not. Okay, a lot of the LLMs that are out there are very like people pleasing. They try to get you to love them in a sense, not in the weird sort of like machine love type thing, but they try to get you engaged with them, because in the end, these machines are intended to make money for their companies. All right, like Google and OpenAI and Microsoft, they're not generating and creating these AIs and large language models for the betterment of humanity. At least I don't think they are, right? They're doing it as a way to get people using the tool so that ultimately they can somehow make money off of it. And so if these AI tools were constantly being negative and not affirming and things like that, people wouldn't want to use them. So you do have to be careful when you use these tools that that they're not being like overconfident or telling you things that they just think that you want to hear and things like that, right? So anyways, that's not really going to have any impact on our course this summer. I mean, Copilot's integration into MATLAB is very straightforward. Its use case is very specific. It's not, you know, you're not going to be using Copilot in MATLAB to help you, you know, deal with like anxiety or loss or something in your life. No, it's there to help you write code and solve problems as an engineer. So our job in that regard is going to essentially be to direct, like help the AI figure out what we want it to do, and then check what it does, verify what it does, and so on. Okay. All right, so let's jump into our toolbox. So first off is the environment that we're going to work with. And so this right here, and you'll see a little bit more when I do a live demo of this, is the MATLAB desktop. Okay. There's a lot of stuff here. And so, you know, most of this stuff, the vast majority of this stuff, you're not even going to need. Okay. There's things in here for, you know, discipline specific work. I mentioned aerospace before. There's stuff in here for doing like full on debugging and all sorts of things. I mean, you might need to touch on some of these things a little bit, but in general, the vast majority of this stuff is very straightforward that you're going to need to use. So the first thing is kind of hard to see. I just highlighted it over there in a little red box. That's the icon that you use to select your working directory. Okay. The golden rule of MATLAB, so to speak, is you always need to make sure that you're in the right working directory. The working directory is like the folder where your files are located. And if you're in the wrong directory, you're not going to have access to your files. So you always want to make sure that, you know, you start off in the right one. It's a little bit hard to see it, but my working directory right now is this users, Jeff Ringenberg, documents, MATLAB folder. Okay. We're going to recommend a different folder for you to create in Lab 1 for putting all your files. But in general, like whatever you decide to use as your directory, make sure that you're in the right directory when you start doing work. Okay, the next thing that I'm highlighting up here is this little plus sign in the upper left. Okay, that is the part of the program that allows you to create new things. In our case, the only like things that we're going to be creating this semester are scripts and functions. They're referred to as M files or .m files. .m, by the way, is the extension that MATLAB uses to indicate like that the file is a file that's associated with MATLAB. Okay, just like a .exe extension is a executable in Windows, and a .docx is a Microsoft document file, or sorry, Microsoft Word file, and so on. Okay. All right, the next thing to pay attention to here in gray here is the editor. So this is where you're actually going to sit down and write your MATLAB code. This editor window may not be visible when you first open MATLAB. In fact, it's probably just going to be the next thing, which is the command window underneath it. When you want to actually open up a file, the next thing I want to draw your attention to is this little open icon up here. That's where you can drill down into the file structure and find the folders that you, or sorry, the files that you want to open, whether they're scripts or functions. If you don't know what those are, we're going to obviously talk about those later on. The next thing I highlighted here is a list of files that are in the current folder. Right now, it's empty. There's nothing there. I haven't created anything yet because it's the start of the term. Next one down here, this is the command window. And as I said, the command window might be the only thing visible here in the center section of the MATLAB window when you first open up the program. And this is where you're going to go to write your code, run your code if you've already written it, look at your output from the code, maybe set up some variables, create them real quick, whatever. The bulk of your work, though, is going to be done inside of the editor, okay, the window that's above it. And this whole structure of the way that this MATLAB window works, by the way, is customizable. Like you can hide menus and open and close menus and things like that, and make the files and workspace, which is another thing. You can make them all disappear, and you can have the editor take up the whole screen. But in general, like this is the default view that you're going to be working with when you start, in lab. All right, the next piece over here, this is the AI assistant. Okay, as I said, the default one here is Copilot. I think Copilot is a Microsoft product. I don't know. At least at first it was, and I don't know really exactly how it fits into this. Like last time I checked, Microsoft did not own MATLAB. It's owned by a company called MathWorks, right? So Copilot's here, and we'll use it, and you'll get to see all the cool things that it can do. All right, and then the last thing down here in the bottom left is what's called the workspace, and this is where your variables, okay, we haven't talked about variables yet, but this is where they all appear as your programs run, at least the variables that are sort of active at the time. Generally, you don't really need to work with the workspace that often, but every once in a while, if you want to see like what variables are currently active and have data stored inside of them, you can see those, and they all appear here. So the main things that you're going to use this summer as you're working in here is going to be the editor. That's where you access your code, or sorry, that's where you write your code. The Copilot chat, that's where you work with your AI assistant. You'll use the command window every once in a while, and then obviously the little menu buttons and things up here is to help you navigate your files and open things and close things and all that. Okay, finally, I just want to reiterate the #1 rule of MATLAB. Always make sure that your current folder is set to the folder where you want to begin your work. Okay, sometimes MATLAB will default to a folder that is not that folder, and if you start working in that, it might be in like a temporary directory or something somewhere, and you'll end up maybe saving data somewhere and then losing it because you log out and then you log back in on a different computer and you're like, where'd it go? All right. There are ways to set your working directory to a default location, but it's buried in the settings and it changes sometimes. And so it's better for me to just say, remember the #1 rule about MATLAB, and that is always set up your current folder when you first start working. Okay, so next, let's move on to writing some instructions. So if you've programmed before, in particular in a language like Java, you'll know that variables are these quote-unquote named containers that allow you to store values or data inside of the computer for later use. Okay, MATLAB has those things as well, but there are some differences to the way that MATLAB handles variables compared to a language like Java, or even Python for that matter. Java is what's called a compiled language, so before you actually even run your code to see if it works, you have to compile it. You have to convert it into a bunch of zeros and ones so that the computer can read it. Computers can't read Java code natively. They have to have it converted into zeros and ones in some fashion. So Java does that in advance. It does the entire program all at once. Languages like Python or MATLAB, these are what are called interpreted languages, and they interpret their code line by line or one line at a time. So over here this is it's the MATLAB script editor. It's not actually the one that's in a MATLAB window like this, right? This is just the script editor that I have in my slides. But this is an example of a few lines of MATLAB code that you can use to set up variables, okay? A, B, and C set to 3, -10, and 5 respectively, okay? Variable names, if you've programmed before, you know there's conventions as to how they're named. MATLAB's main convention for naming variables is they have to start with a letter, so an alphabet character. Yeah, so like A through Z. And then after that, it can be followed by more letters and numbers and the underscore and so on. But in general, if you just stick with letters and numbers and making sure that your variables start with a letter, you're fine. You don't have to worry about anything. One thing I want to note here, and before we move on, I'll talk about it some more later, is that the percent sign here is the start of what's called a comment in MATLAB. So we'll talk more about comments in a sec. All right, as far as doing calculations in MATLAB, here's a list of the basic operators that MATLAB supports. If you've programmed before, you've seen these. Plus, minus is addition, subtraction. The star is multiplication. The slash is division. And then MATLAB also supports exponentiation with the caret, which is Shift 6, I believe, on the keyboard. Okay, exponentiation is like x to the y power. So if you wanted to do x to the y, you would do x caret y. Some programming languages have a function for that called pow, but MATLAB actually has a character devoted to that, the caret. Okay. As far as the example that we're working with here, remember I said we were going to be doing the quadratic equation right here. Okay, so we want to be able to build up that quadratic equation in MATLAB code, and so that's what we're doing here with these lines of code. This is establishing values for A, B, and C, and then here we're establishing what's called the discriminant. So it's the value of b squared minus 4ac. All right. There's all sorts of other rules as far as how operators work with respect to whether or not data is stored as matrices and arrays, but we're not there yet. Right now we're just going to focus on our variables storing like numbers. And that's it. Okay, last thing I want to talk about so that we can actually see the result of the work that we're doing is the use of what's called the disp function. Okay, the disp function is used to essentially print out the value that is inside of a variable or to print out a line of text. Okay, so there's ways of doing this in Java, there's ways of doing this in C++, there's ways of doing it in Python. They're all different, but they all effectively do the same thing, which is allow us to either print out a string of text or a line of text. In this case, discriminant is colon, and they also allow us to print out the data that is stored inside of our variables. So in this case, from the previous slide, we had this variable called discriminant right here that was set equal to b squared minus 4ac. And so on this slide, if we were to execute this code inside of MATLAB, it would print out discriminant is, and then after that it would print out the actual value that is stored inside of this discriminant variable that you see right here. Okay, and that output from this disp function shows up in the command window. So if we go back here to our little MATLAB thing, it's going to show up down here in the command window after you run the code that executes that function. All right, so this is what if the command window was in the program, that's what it would look like right down here. It would just say discriminant is and then 40. So 40 shows up on its own line. It doesn't come after the colon, it comes on the line underneath it because MATLAB just by default puts new lines, or it hits the return key or the enter key after each execution of the disp function. Okay, finally, comments. So as I said before, those things that you saw that were preceded by a percent sign, those are comments, and comments for a computer are ignored. Okay, computers don't care, compilers don't care, interpreters, they don't care about comments. They're completely ignored, but for humans, they're absolutely essential. Okay, they essentially allow us to convey information about what the code is doing or maybe how the code is doing it that goes far beyond just looking at the code itself. So in this little example here, we have obviously the simple little things at the top that say these are comments, they help explain my code. But down here for a equals 3, you can also explain like what are we doing with this line of code. Obviously this comment right here, it says I can also put comments at the end of the line. That's not telling us what a equal 3 is actually doing. But if we had a longer set of code that did some stuff, and you'll see that as we get into later examples, these so-called inline comments are essential, all right, for when you hand off your code to another human and you expect them to understand what your code is actually doing. Okay, if they can't just look at the code and figure it out on their own, which is usually not the case. Okay, so now what about the rest of that formula? Well, right now we could sit down and do the rest of that formula by hand, or let's step into the world of the AI assistant with the understanding, as you can see here in the red box, that those AI assistants sometimes write code that might look accurate, but it's not. Okay, it actually mentions or plays out this little warning twice, here and then also down here. Validate generated code before use. So for the most part, it's correct, but every once in a while it screws things up. All right, so you have to be careful with that. All right, so let's talk about the workflow here as we discussed before. So you are taking the role of the lead engineer. Okay, your job at this point, at least in this specific example, is to give the AI high quality prompt. In our case, we're going to use Copilot, but there are other AI that you could use as well. So you just have to pick whichever one you think is the easiest for you. Obviously, Copilot's the easiest for MATLAB, but outside of MATLAB, I actually prefer using Google's Gemini. That seems to be the most effective one for me. Okay, but what's not the easy part is figuring out what prompt you're going to give to the AI. Okay. In this case, I've given a prompt here that we're gonna give to Copilot, and then we're gonna look at the results. And this is almost always going to be the hardest part of the process. So the AI prompt that we have here, it just says, write a MATLAB script that calculates the roots of the quadratic formula given a equals 3, b equals -10, c equals 5. And then we tell it the script should display the final roots. So, it's essentially what we've done so far, but it's going to be the entire thing, the whole process. All right. Yeah, so now what we need to do here is we need to generate this code. So I'm going to drop out of here, and I'm going to see if I can do this in real time. So I'm going to take this prompt. It's a little bit clunky. I'm going to take that. I'm going to go over to MATLAB, and I'm going to go to Copilot. So I think I'm running this live here. And I'm going to go into Copilot, and I'm just going to paste that prompt. So write a MATLAB script that calculates the roots given blah, 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 blah. And then I'm just going to hit run, and it's going to go. And if I want to interrupt it, I can hit the stop generating thing, but I obviously don't. And so now let's look at the results here. So it says you can calculate the roots of the quadratic equation, and it gives it using the roots function in MATLAB. Oh, okay. That's not actually how we had planned it. Based on our plan, we had that whole equation, the quadratic formula that we were going to use with the square root function and all that business. But MATLAB is saying that there's actually a roots function that we can use. So if we look down here at the code that it gives us, it looks like it's not even really let's hide some of this stuff, by the way. There's over here on the left, if I click that, whoop, the files thing and the workspace thing went away. And you can also do the same thing for Copilot. You just click this little button right here, and that hides that. But I don't want to hide Copilot. I want to see the whole thing. So I'm going to stretch this out a little bit. And so let's look at the code. It says, here are the coefficients. So this is where some comments come into play being useful. So coefficients. So that explains to us that the next 3 lines here, those are the coefficients that we're working with. Then the next line, create the polynomial coefficients vector. So we haven't talked about vectors yet. So this, that doesn't really make much sense to us. And then this vector is stored into a variable called p, which we then provide as an input to this roots function. And then ultimately, we display the results. And so, this is the script, but I actually haven't run this script yet, so I don't actually know if it works. But it turns out MATLAB has a fun little green arrow right here. If I click that, pretty sure it runs the script. And so let's hide the Copilot window for now and look down here at the command window, and you'll see this is what happened. All right, there's the code, there's the script, and then down here at the bottom, this is the output of the script. The roots of the quadratic equation are 2.728 and 0.6126. All right, so right there is the solution to the problem. Okay, and it used this roots function. Now, I'm not too excited about the fact that it used the roots function. In fact, I knew that it was going to do it. And so the next thing I want to talk about here in our slides is just a little bit of how to work with a refinement of these tools. So let's jump back into our slides here, and we'll talk about what I mean. I may have to fast. Oh, no, went right there. Okay, so we're now at the part where we have to verify the AI's work. So some questions that you want to ask yourself. Are the variables set up properly? They look like they were. A, B, and C got values. Is the math correct? We could verify it by hand, but I'm almost positive that the 2 roots that were provided there were correct. Are the outputs displayed properly? Yeah, they looked like they were. I mean, it had the, roots are, and then it gave the values. And then finally, does the code or even the prompt need to be changed? for the most part, it worked, right? But if you recall, the code that Copilot generated used the roots function, and I don't want to have to figure out how the roots function worked. Okay, it's nice that it used it, and I'm glad it did, sort of, because it gave me a nice example here. But really, what I really wanted it to do is to use the full quadratic equation that we talked about earlier. So what we can do to make that happen is we can actually modify the prompt. We can go into the prompt and say, instead of just write the script with the following values and then display the final roots, we can add this little bit that says without using any built-in functions. Okay, so let's switch back over to MATLAB then and queue up our Copilot here and give it this modified prompt, and let's see what it does. Okay, so it's generating away. Yay! It's not super fast. Okay, there it goes. And then finally, here's the code that, if you look close, let's see if I can spread this out a little bit. If you look close, it's not using that roots function anymore. Okay, it's actually calculating the discriminant that we had talked about before, right here. And then it's doing a couple of things. It's actually doing quite a few things. And this is a situation where maybe we should have just used the roots function, because there's a lot of code here that's different than the code that we had from before. Okay, so here we have, if D is greater than 0, if the discriminant's positive, 0 or negative, whatever. If the discriminant's positive, then we have to do this, and then we have to display the roots as this. But if D is equal to 0, there's only one real root, and so then we have to do this, and then so there's actually a lot more code happening here that we can't really talk about yet, unless we've talked about how selection works in MATLAB, which is something we're going to talk about soon, but we haven't gotten there just yet. If you've programmed before, feel free to dive into this and see if you can understand how this code works, right? But in general, like, I'm gonna leave that for now, and maybe y'all can revisit that after we talk about how selection works in MATLAB. MATLAB selection is not exactly the same as selection in other languages. Okay, so let's just play this one or run the script and see what it does. I'll hide the Copilot window, and it shows the whole script here. And if we compare the result from the original one that used the roots function, 2.7208 and 0.6126, those are the same values that show up down here. So both versions of the code generated the exact same results, but they did it in two different ways. One way was using the built-in roots function. The other way, all the math. Okay, and a lot more complex stuff there. As far as to what you are most comfortable with using, it's really up to you. The roots function is nice because it's cleaner. It makes use of a function, which is what we're going to talk about in the next lecture. It helps to hide some of that complexity. But the second version just gives you all the info that you might wanted to see, and it gives you the ability to, like, go in and fix things at a much finer level of detail than what the version did that had the roots function. Okay, so anyways, that's how you can use the AI to do a couple of different versions of the code. And then the last thing I want to do now is just go over real quick, summarize what we talked about today. All right, so today we discussed that programming is about building tools to solve problems. Today the problem was very simple. It was the quadratic equation. We looked at our toolbox, which is the MATLAB environment, and some of its core syntax, like how to create variables and how to do a little bit of math, how to output the results, and so on. And then we spent some time at the end doing the sort of prompt, generate, verify workflow. And we even did a little bit beyond the verify. We did a bit of a modify at the end, where we told it to generate code that didn't use built-in tools. Okay, so anyways, that's all that I have for today. Now it's time for you to head out and start working on this stuff in lab, and try your hand at using a little bit of AI and Copilot in MATLAB. And next time we'll start digging into using functions and getting rid of repetition in our code, and so on. So with that, have a good one, and I'll see you next time. Bye-bye.